When you think about healthcare, this is a huge part of our economy, and then many of us think that it could be run more efficiently. So when you think about industrial engineering and efficiency, we're trying to allocate these scarce resources in the most efficient way possible.
One of the big applications nowadays is how to improve hospital operations. We want to make the waiting time in the emergency departments shorter. We actually hang on into the psychology of waiting, which basically says if people wait in the queue, when we tell them how long they should expect to wait, and we overestimate a little bit, their satisfaction went up. The queues are still long, people are going to wait for 10-15 minutes, but that 10-15 minutes is going to feel like 3 minutes.
It's a really delicate balance in those first few weeks for babies who are born preterm. So we're looking at optimizing nutrition in NICU units. And I think that data science allows us to really tailor the nutrition to the individual infant. We have access to so much information, but how do you know what's critical? What really is impacting growth?
I'm working on a project to identify the source of substandard and falsified pharmaceuticals using post-market surveillance. The problem that oftentimes regulators face is they can measure if a product is good or bad, but the only place they can really measure that is at the end user level. The question is then, how do you take that information about the end product and infer what's happening in the supply chain?
Turns out that about 20% of donor kidneys get discarded every year. We have already demonstrated that there is some home for this viable kidney. The next problem on the table is really making sure that every viable kidney finds a home. The change in the health system is going to have to come from systems thinking, and not only that, but also engineering mindset.